Hi, eighth graders. Happy Monday. Hopefully, you guys had a wonderful weekend of doing probably nothing. But I'm hoping that this week goes nice and easy, goes by quick. And then next week, you guys have spring break. So you got a kind of a break from e-learning and being on your Chromebook constantly. And you can take some time to enjoy your time with your family and your friends virtually, though. Stay inside and wash your hands. We are going to continue this week with reviewing previous units that we've looked at this year. So today, we're actually going back to Unit 1, which is around September, October-ish. So these are in the early parts of your ISN. We're going to be looking at how to convert a repeating decimal to a fraction, super easy skill. We're going to look at how to identify rational and irrational numbers and then how you can prove that, and then how you can approximate irrational square roots on the number line. Again, it seems like it was 1,000 years ago that we did this stuff, but I think once you kind of see it, you'll get back into it and you'll remember. All right, so let's get started. When we're talking about repeating decimals, they can either look like this, where you've got a pattern like 3, 4, 3, 4, 3, 4, 3, 4, and then you see the dot, dot, dot here, or it can show that it has the line on the top of it. So this line shows you that it's a repeating decimal, so that would again show you 3, 4, 3, 4, 3, 4, 3, 4 going on forever. So your two clues that you got a repeating decimal are the repeated pattern with the dot, 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 or the line that's here. Now, to convert these to a fraction, all you need to do is look at the pattern and identify how many digits are in the pattern. That's how many nines are going to be on the bottom or in your denominator. So if you're looking at this first one, it's 0.2222 going on forever and ever. 2 is the only digit that's in that pattern. So technically there's only one digit. Therefore, in your fraction, it would just be 1 9. So if you see 0.2 repeating, 2 over 9. 0.4 repeating, 4 over 9. If you're going down, if it's 4, 5, 4, 5, 4, 5, I see that there are 2 digits in this pattern, which means that the pattern here, 45, will be my numerator, and there will be 2 9s my denominator. 0.976 repeating, this 976 will be my numerator. My denominator will have 3 9s because, again, I see 3 digits. It looks just like this. And then if you've got 0.1234 repeating, this 1, 2, 3, 4 is my numerator because that's your repeated pattern. And then because there are 4 digits, there will be 4 9s. Hopefully that's super easy, quick reminder for you. If not, we have notes on it in your spiral. All right, moving on. Let's review what a rational and an irrational number is. These are 2 different types, and each number can be categorized as either rational or irrational. For a number to be rational, you have to be able to write it as a fraction. Notice that the word itself has the word ratio in it, so that's your clue. For something to be irrational, it's a number that cannot be written as a fraction. And we'll look at like a few quick tips and like hints that you can kind of use to help you categorize the 2 numbers. Remember the acronym that we talked about long time ago to recognize rational numbers, and it is RIFTS, R-I-F-T-S. R stands for repeating decimals, which we just looked at a few minutes ago. I stands for integers. F stands for fractions. T stands for terminating decimals. Remember that terminating decimals are decimals that end, they terminate. And then S stands for square roots of perfect squares. So we're going to go through a quick example of each and prove that they are rational. And you'll need this for your school G-Check too. Okay, so R stands for repeating decimals. For you to prove that something is rational, you have to be able to write it as a fraction. That's why we spent all that time going through the lesson and showing that a repeating decimal can be written as a fraction. It's proving that it's rational. So if I see 0.575757, number one, I know it's rational because I know I can write it as a fraction. To prove it, it's going to be 57 over 99. So there's my proof. If I had 0.378 repeating, I know it's rational because I can write it as a fraction. It'd be 378 over 999. So I proved that they're both rational and repeating decimal, so those work. Integers are any positive or negative counting numbers on the number line. So it could be like 10, -5, 100, -17. We can also prove that these are rational by writing them as fractions. So like I know that 10, you can write that as a fraction as 10 over 1. If I was looking at -5, I could write that as -5 over 1. Remember, with integers, they're always going to be written as fractions over 1. So that's your proof. Fractions are already fractions. So obviously they're rational. You can write them as a fraction because they're already like that. So you don't need to do anything to prove it. Okay, terminating decimals. We struggled writing these as fractions, remembering back to 6th and 7th grade. So number one, because they're terminating, meaning you don't see any digits coming after, you don't see dot, 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 you don't see the line, you know they're going to be rational because you can write them as a fraction. If this was 0.5, you would formally say that as 5/10. So as a dot or as a fraction, it'd be 5/10, just like that. If you were formally saying this one out loud, it would be 37/100. So because you can write these as fractions, you've proved that they're rational. Another hint for you, if you have one digit in your terminating decimal, you should have 1 0. If you have 2 digits, you should have 2 zeros. So it's a good way to make sure that you're doing it, okay? All right, last type of rational number, square roots of perfect squares. If I'm looking at the square root of 25 and I asked you, all right, what is the square root of 25? Most of you would tell me 5, which is correct. But you still need to prove that you can write that as a fraction. We just did that 2 seconds ago, though, when we were looking at integers. The number 5 can be written as 5/1. So that works. If I asked you what the square root of 100 is, you would hopefully tell me 10. And I know that because 10 is an integer, I can write that as a fraction as 10/1. Now, when we're talking about irrational numbers, notice that I've got the square root of 17 here. There is no perfect square root of 17. If you put that in your calculator, it would give you like a whole bunch of decimals. That's why it's irrational. So here are 3 easy ways that you're going to see irrational numbers, or numbers that you can't write as fractions. You'll see decimals going on forever and ever with no pattern. You could see square roots of imperfect squares. Again, and if you don't believe it, put in your calculator square root of 17 and then type enter. It's going to give you a number that looks like this. Or you could even see pi, because that's 3.14159, goes on forever and ever, has no pattern. So irrational numbers, like all of these pink slides over here that we just went through, these can all be written as fractions, therefore they're rational. Numbers like this, though, that I know in class we call them hot mess numbers, they can't be written as fractions, therefore they are irrational. Okay, moving on to your last skill for today. If you have your spiral notebook with you, which you should, because we yelled at you at your lockers before you left last week, open up to this page, because this is definitely going to help you, especially with your Schoology check. For me, it was page 19. I don't know what your page is. So go find this page in your spiral. It's going to help you not only for the last part of the lesson, but also for your Schoology check. All right, when we're looking at a number line, it is helpful for us to understand what the perfect squares equivalents are above our integers. And if you're not sure, like I know 1 times 1 is 1. So the square root of 1 is 1. I know that 2 times 2 is 4, therefore the square root of 4 is 2. I know that 3 times 3 is 9, therefore the square root of 9 is 3. And you could keep going on and on and on until you fill up your whole number line. Again, we were great at this, doing this in class, and I was kind of prompting you, but it might be a good idea for you to have this open in your notebooks. It's going to help you. Now, when we are approximating irrational square roots here, these numbers like square root of 17, you are going to look to find the 2 integers that it falls between and then which one it's closer to. So if I'm looking at the square root of 17, I know that that's going to fall in between 4 and 5 because I see square root of 16, square root of 25. So obviously it's going to be right here. And so it's between 4 and 5. And 17 is really close to 16. So I know that it's going to be closer to 4. Let's try another one. If I'm looking at the square root of 78, I'm going to go down my number line and be like, all right, where does 78 fall? I see that it would fall between 64 and 81. So it falls between 8 and 9. And then ask yourself, is 78 closer to 81 or is 78 closer to 64? And I say it's closer to 81. So that means that it's going to be closer to this 9 here. All right, one more example. If I'm looking at the square root of 40, look through your number line, where does it fall? And I see that the square root of 40 would fall between 6 and 7 because 40 falls between 36 and 49. But your last part is like, okay, does 40 fall closer to 36 or does 40 fall closer to 49? And hopefully we can see that it would fall closer to the square root of 36 because it's only 4 away. Therefore, it's going to be closer to your integer 6. So like on your Schoology check, if you were filling this out, you would tell me, okay, square root of 40 is between 6 and 7, and it is closer to 6. If I was going back here, I'd say, all right, the square root of 78 is between 8 and 9, and I see that it's closer to 9. Okay, if I was going, sorry, right back here, I know that the square root of 17 is between 4, oh wow, and 5, and it's really close to 4. So you'll see that in your Schoology check. Have your number line open, or you can also just use your phone, take a quick picture of this because that'll help you out. All right, your Monday assignment for today to practice those 3 skills is a Schoology check. You can take it 2 times for your highest score. Please do that to make sure you're getting 100%. Other than that, thanks for tuning in. Hope you guys have a wonderful day. Please don't hesitate to message me. I miss you guys so much, so I'm always happy to hear from you. All right, bye.